Hey, what's up guys and girls, and welcome back to another video. Very excited for this one today. We're going to be going through the Scikit Learn library of Python, which is a very important library for machine learning in Python. And definitely this video was pretty highly requested, so I'm excited to finally get to it. So what we'll specifically be doing in this video is we're going to be kind of slowly walking our way through the Scikit Learn library and kind of showing all the different avenues you can go. But our ultimate task that we'll be building in this video is going to be two different machine learning models. The first model is going to automatically classify text that we put in as positive or negative. So for some examples, if I ran this line of code right here, I thoroughly enjoyed this, 5 stars. That's positive. Bad book, do not buy. That'd be a negative example. Very interesting stuff, thank you. That's positive, and as you see, the machine learning model outputs corresponding values. I could change this to something like horrible, do not buy, or I already said do not buy, horrible, waste of time, and that will, now we'll see this switch to -2. Cool. So it automatically knows, if these are positive or negative, and this could be applied to all sorts of cool things. I could, incorporate this model into my YouTube comments and see how much positive, how much negative stuff I'm getting. So it's really fun kind of playing with actual text data and creating a Scikit Learn machine learning model and I guess getting this as the output. Then we'll do one other task, which is very similar. The model doesn't change too much, but it's just kind of cool to see a little bit more what you can do with the same type of sklearn stuff. So this is also an NLP, natural language processing model. And this one, instead of positive or negative, we have these several different categories that we're kind of grouping our comments in. And kind of the way you can think about this one is, imagine you're in charge of Twitter, HR, and you're getting all these positive and negative feedback to your Twitter account, but you don't know what products they're talking about. This machine learning model automatically classifies text as a certain category. So great for my wedding would map to a clothing category. I loved it in my garden would be patio category, and good computer would be electronics. And as you see, that maps correctly to these things. So those are the two models we'll be building. We'll be walking through all sorts of cool stuff with Scikit Learn. Quickly, let me just cover the timeline of this video. And this will be in the comments, so make sure to check that out. We're going to start out with kind of just a brief overview of why you use sklearn, what's its purpose, when you should use it, when you shouldn't use it. Then we'll jump into loading in data into sklearn and what sklearn can do to help us with that. Then we'll be choosing our classifier. Once we choose our classifier, we'll be evaluating the performance of the different classifiers. We'll be doing some fine-tuning of the classifier to make it even better. Trying to think if there's anything else. We will also save our model so you don't have to retrain it every time if you wanted to use it in production. And also, I just wanted to say real quick, this is a fairly long video, so if you want to break this up into 15-minute chunks, I'm going to try to structure it so it's pretty easy to do that. So don't feel like you have to watch this whole video at one time. Watch one chunk, come back to the second part later. But I kind of want to keep it all together because I think it's good to kind of see the full, from start, from data to final model avenue. Okay, so a little background information on sklearn and machine learning more generally is that I would say that pretty much every machine learning task has several steps associated with it. So, at its core, any sort of machine learning thing you want to do, you're going to have some sort of question that you want to answer. So that's always the first thing. You have this question that you want to answer. And then you need to find some data that will help you answer that question. You can build a model around that data. Once you have that data found, and you'll probably have to do some prep on the data, some sort of processing, some sort of filtering. Once you have your data all prepped, you're going to want to build some sort of model around the data. Once you have a model, you're going to next move on to doing some evaluation. How well is your model performing? And kind of after that, you'll make improvements. You'll tune the model, you'll find different parameters, you'll maybe tune your data a little bit more, and just try to improve your model as much as possible. sklearn helps simplify that entire pipeline. They help a lot of common things you'll want to do to improve your model and to get your model ready to be built, or actually using a specific algorithm for the model. sklearn packages all of that up into a nice library for you. So a little bit more detail, like I'm here looking at the sklearn site. There's all sorts of classification algorithms that are out there, and here is some code for a certain classification algorithm. And as you see, it's a little bit long and convoluted, but with sklearn you can use that same algorithm in a couple lines. Same thing with regression, clustering, everything that might take a lot of your own code to do. sklearn has already packaged that algorithm up for you, and it's easy to just use yourself. Another separation I want to make real quick is that I would say there's kind of two types of models that you can build in machine learning. So this is very general. On the one hand, you have the neural network, the deep learning models, and then on the other hand, you have these traditional algorithmic type machine learning models. sklearn is really, I think, helpful in this traditional algorithmic models. They have packaged up all of this stuff for you to use from the algorithm side. For neural net type stuff, we're not going to be covering it in this video, and I looked at some stuff on the documentation. They have a little bit of neural net stuff, it looks like, in sklearn, but I would really recommend, if you want to get neural network machine learning experience, check out either TensorFlow. I use PyTorch personally a lot. There's other libraries that really jolt around neural networks. So we're focusing on that traditional algorithmic approach side here. Okay, so now that we've gone through a little bit about sklearn, let's go back to the question we're originally trying to answer, and that is automatically classifying comments as positive or negative. And to do this, we first need some data to train our model. The easiest approach, like the initial stupidest approach you could do, is imagine me just going through, mainly writing like stuff like, and that would be negative, or stuff like Keith is the best. That would be positive. I could do this, but I would be here for years, basically creating enough data for the needs of this video and to make a good model. So yeah, manually creating data is probably not the best approach. You could crowdsource and get a lot of people to manually create you data. That could work potentially a little better, but still time consuming, probably costly, not the best. So the best approach to getting data you need is try to be creative. How can we find data that will help us do what we need that already exists? And for this positive negative feedback model, the place that I'm decided to go was Amazon.com. So, we click on anything like this cute little, oh my gosh, this is so adorable. This cute little costume, and we can go to the reviews, and the reviews basically here are reviews of any product basically have already labeled data for us. If something is 5 stars, this material in here is going to be very positive. On the other hand, let's see if we can find a 1 star. I don't know if I'll find it with how adorable this costume is. Okay, yeah, we have a 1 star review right here. Maybe make this a little bigger. This is not quality at all. In this 1 star review, we have negative feedback. We have negative things that people are saying. So if we can take a lot of Amazon reviews, we can use that as our training data. So that's exactly what we're going to do. So what I ended up doing, and I made it a little bit simpler for you, is that this guy, J.M. Galli at USCD, did a lot of work for us where you don't have to actually scrape through Amazon, but from 1996 to July 2014, he collected all sorts of Amazon review data. So I went ahead and took some of that and broke it down. I have a script that shows exactly how I did it that I'll show you. But I just kind of broke that down into a more manageable amount of reviews for several of these categories here from the year 2014. So that's what we'll be using as our data, as our training data. Okay, to get that data and begin actually writing our code, I need you to go to my GitHub page /Keith Galli. This will also be linked to in the description, and yeah, Keith Galli /sklearn. And while you're at it, follow my GitHub, because the more milestones I hit, more fun pictures like this I gotta post. Okay, and so once you're on the GitHub page, you're going to want to go to data, And to begin, I recommend just going to Sentiment and downloading this file that I called Books Small. So this is 1,000 Amazon reviews from 2014, specifically on books. So go ahead, you can click on that. And if you click on that, there's somewhere to, just download the raw file here. Or you click raw and then you can do save as. So Books Small and text document should be fine. Or maybe just even do all files and just do .json. Don't mind where I'm saving it. Yeah, so I'm just saving it. I already have it saved, but yeah. Save it somewhere that's close to where you're writing your code. Okay, open up your favorite code editor. I personally like Jupyter Notebooks for anything data science related. And let's actually start diving into the machine learning tasks. So to begin, before I write even any code, let's just look at our data again. And I guess for the first time. This is what our data looks like. This Books Small that I told you to download, it looks like this. So it's a JSON file, I guess, and each line is another JSON object. So we're gonna have to, if we wanna like load this in a logical way, we're gonna have to load in this file line by line. And then what are our important fields here in this JSON? So I see we have this review text, and that's actually what is the text content in the review, so that's important. So we're gonna want that. And then the other thing that is going to be important, oh my gosh, this is a long one, is going to be this overall. That's the out of 5-star rating. So those are the two fields that I really care about. And then we can kind of do some additional stuff with that. So that's our file, and let's start processing that. So one thing I recommend is let's first import the JSON library. That will just allow us to process that file. And then if we're going to want to load this in line by line, this is what we can do. So we're going to go, well, first off, we need to know our file name. And our file is called the path that I least saved mine in. And this is relative to the code that I'm writing. It's within the data folder. And then it was within the sentiment thing. And it was called Books Small .json. So that was my file name. You might have something different. All right, and now we'll want to open up that file, so we can type in with open file name. What the heck, as F. So we're opening this file name as F. So the file is called F. And then what we can do is for line in F. And just to see what we have right now, I'm going to just do a print line. And this is Python 3, just a heads up, so I have to surround it with the parentheses. And I'm going to break out a loop because I don't want to run everything right now. Okay, cool. So I did get something out of that. And now what I want to do is I want to quickly, what do I want to quickly do? I want to get the review text. So we want to get, and the overall. We want to get the review text here. And like this is definitely a positive thing. It's 4-star overall. Like, divined by storm with this unique new novel. She develops a world unlike any others. So this all sounds good. And this is about books. So let's try to get that review text. So a printed line. Normally if this is like loaded in as a dictionary, we should just be able to do line and then review text like this. So let's see if that works. We get an error. And so the reason we get an error is because right now this is just raw text. So we need to use this JSON library to actually load it in as a review, like dictionary basically. So we could say something like review equals JSON dot loads line. And now if I print out review of review text, we should get what we're looking for here. Oh, why did I type an S? Cool. Now we just get that text, and if I just wanted that overall score, I could do review overall. That was the JSON key that will produce the right value. What did I just do? 4.0. Cool. So that was the 4 stars. So we got both the things we wanted. So now what we really need to do is just gather this all in a nice way. So I'm going to get rid of this break statement, and I'm going to say reviews. That's going to start out as an empty list. And what we're going to do is we're going to just do reviews.append, and maybe we'll append a tuple object of review text, and the score. And the score. I can go ahead and delete this because I don't want all of it to print for all of 1,000 lines. And to just check to make sure it works, let's print out like a random object in that. So I'm going to just go with like review number 5. Love the book, great storyline, keeps you entertained. For a first novel from this author, she did a great job. Would definitely recommend. So this is a very positive review. I'm surprised that they gave it just 4 stars because they could have gave it 5, but whatever. But yeah, as it looks like it loaded in properly. And now if we just wanted to access like the review, we would just do 0, and we would, if we wanted the text or the score, we'd do 1. Well, this does work with this whole indexing to get like the score and the text. It's not the neatest way, and I think one issue I see with a lot of like data scientists and machine learning engineers is that it gets messy. Their data gets messy. It gets hard to parse through someone's code. So what we're going to do real quick is make a data class for our all of the data that we're loading in. So I'll do this above. So we're going to call this class review, and we're going to initialize it with, you always have to initialize it with self, text and score, and basically self.text will equal text and self.score. The score is equal to star, like the number of stars is what I'm saying with that, is equal to score. And then we can do some additional stuff within this class to like convert this score to a sentiment, and ultimately having this class will make things neater. So now what we're going to do, instead of appending this tuple, we're going to go ahead and create a review object. So review, and then we're going to pass in the text and the score. So we already actually have that here. Text and score. So now, instead of doing one index to get the score, I can do reviews5.score. And as you see, it stays the same. And if I did the text.text, now I can easily get the text. It's just a little bit neater and helps you kind of keep track of things. And we're going to do a little bit more within this class. So one thing I want to do is initialize some sort of sentiment. So I can do self.sentiment, and for sentiment, 4 or 5 stars means positive, 1 or 2 stars means negative, and then I guess we can use 3 as like neutral. So I'll create a function within the review class called getSentiment. All functions within a class pass in self, and so what we'll do is, and I'll set this to self.getSentiment. So once we fill out this answer, it will return whatever this function does. And okay, so if it's 3 or 4 or 5 stars, it should be positive. If it's 1 or 2 stars, it should be negative. So I'll start with a negative. If self.score is less than or equal to 2, then we want to set or we want to return negative. And I'll just use strings for now. Elif self.score equals 3. This is going to be a neutral case. I don't know if we'll actually use this at all, but I just want all of our possible scores to be covered. So that's neutral. And finally else, this is going to be a score of 4 or 5. That is going to be return positive. And another small thing that I like to do whenever possible is I don't like having just strings floating around. I like to be very consistent with those strings so I don't actually accidentally like type the wrong thing. So I'm going to actually create an enum class, which is just a regular class, but you kind of call them enums in programming speak. And I'm going to call this sentiment, and that's going to have a couple different properties. It's going to have negative equals negative, and you'll see why I'm doing this in one sec. Neutral equals neutral, and positive equals positive. So the reason I did this is because now let's I'm going to run this again, and I'm going to run this again. I can now do something like reviews.sentiment. So remember, this is a 4-star review, so it should be positive. And it says positive, right? That's fine. We said that here. But now basically instead of always typing out the strings negative and neutral and maybe forgetting that we capitalize the whole thing or spelling it wrong, we refer to these things as the sentiment class. And we do sentiment.negative or sentiment dot positive, or no, sorry, this is neutral and sentiment dot positive. It's just really to ensure that we're being consistent. It's also kind of nice because it's a lot of our code editors can auto recommend this to us. But now if we go run this and go back down here, it still says positive. It's just a little bit neater having this type of thing. You don't have to do that though, but just something I like to do. Okay, so we now have this review class that automatically fills out the positive or negative sentiment. So we're getting there. All right, next let's go ahead and do some further prep of our data. And basically what we're going to be doing next is, let's just take this text again. Basically the issue is when we're dealing with text data, it's really hard to build machine learning models around text data. Machine learning models love matrices and numerical data as input, numerical vectors. So we're going to talk about some ways to convert text into a quantitative vector. And we're going to be using bag of words to start. Real quick, to understand how bag of words works, if you don't know already, imagine we have these two phrases. This book is great, and this book was so bad. So the way we do bag of words is we first break this up into like a dictionary of tokens or words. In this case, we'll do unigram, so just single words as our dictionary. So we'll break that up. So we have this book is great. Sometimes you might optionally include this exclamation mark, but it kind of depends on how you're vectorizing this. Then we also have from the second doc, was so bad. So if we were training a bag of words model, we'd use all of these words to create this sort of dictionary. And then to actually convert this word into a numerical vector, all we have to do is map ones and zeros to the terms over here. So this book is great would have ones mapped to the first 4 words, but it doesn't have was, doesn't have so, doesn't have bad in it. So those would be zeros. Ones where the word is, zeros were not. This book was so bad, that would look something like this. You'd have this book, they both exist. Is not in this sentence. Great is not in this sentence. Was so bad, those are all in the sentence. So this would have been a fit transform process for bag of words, the CountVectorizer on all of this. One last thing is if you wanted to now transform a word or a sentence you hadn't seen before. So imagine we have was a very great book. One small detail about this is A and vary weren't in the original training set. So we actually end up like dropping those terms out. We don't know what to do with them because we didn't see them when we were fitting our vectorizer. But with bag of words for this, if we saw this in like testing time, that would be converted into 0 for this, 1 for book, great is a 1, was is a 1, and everything else is a 0 that isn't existing. And then we can't handle A and vary because we didn't see him at training time. So that's at a high level how bag of words works. One last thing before we start actually using bag of words. In pretty much any machine learning task you want to do, you have some set of data. And so right now we have all of these reviews. And we have 1,000 reviews total right now. If I'm not mistaken, I can double check that. Yeah, so we have 1,000 reviews right now. But whenever we're building machine learning models, we want some subset of that to be training data and some subset test. And basically the common pattern with sklearn is they have nice methods to do pretty much most things you would think people would want to do frequently with machine learning. So in this case, we want to split that 1,000 into a training set and a test set. So what I would do when I'm like doing this on my own is I just would literally look up sklearn training test split or something like that. And there's a couple different options that pop up right here, but usually your first result, if you Google something pretty straightforward, will be what you're looking for. So we have this train test split. It has all sorts of information about it. One thing that's really actually kind of cool, someone commented this the other day, is okay, so how do we import this? Let's see some usage. Okay, we can do this. Okay, so we're trying to split our 1,000 reviews into a training set and a test set. So I was just showing you the documentation, but what's actually pretty cool is if you are using a Jupyter Notebook like I am, if you do Shift plus Tab on that function, it gives me those same exact documents basically right here in my Jupyter Notebook, which is pretty neat. So split arrays or matrices into random train and test subsets. That sounds exactly what I want. I can go down even farther and look more about it. One thing I'm noting is test size. If float should be between 0 and 1.0 and represents proportion of data set to include in the test split. So that's the first thing that I am noticing is important is test size. I also note we can just pass in any sort of arrays and it will take care of those. Let's see. You can also specify train size. Random state is another important one. This basically allows you to seed your random split. So if you wanted to repeat the same exact split in multiple instances, if you just set this to some value, anytime you set it to that same value, you'll get the same exact split. Stratify also could be important. Basically, it would keep the proportion of class labels. So in our case, sentiment.negative, sentiment.positive, the same in both splits or relatively equal. So it wouldn't just like take all the positives in one set and all the negatives in the other by accident. Okay, so let's pass something in. So we want to pass in our reviews. We want to give it a test size. So let's say our test size is going to be 0.33. 33% of the reviews will be what we can use in test. That means that 66% is training. And I'll also give it a random state so that we get the same thing every time. And what does this return? That's the last thing I want to look at. So I'm going to just highlight this again, Shift Tab. Where's the return? Returns, list, and okay, so it returns an X and Y, looks like. Oh, okay. No matter how sorry, I was just reading that and I got a little bit confused. So no matter how many lists you passed in, how many arrays you passed in, it's going to output 2 times that. So in our case, we're just passing a single reviews list. So we'll get an X and a Y back. Or sorry, this is not X. I guess this would be more appropriately training and test. Let's run that. So if we look at the length of training, we took 66% of things. So this should be 666 about. I don't know how it's going to round, but let's see. 670. Okay, very close. Yeah, I guess 33% exactly. We didn't specify a third exactly. And then test should be 330. So you see how we nicely split that up into a training and test. So now what we're going to do is fit our bag of words model to the training set. We'll build a classifier on that training set, and then we'll test everything on our test data. All right, so we want to pass our training set into our bag of words vectorizer. Let's just let's like print the first row of our training, our first training review. These are all reviews. Okay, and this is still the object. So if I wanted to print the first text, remember we can do this. Cool. Okay. So this is a positive review. Let's just check. So remember we can do sentiment. Just remind yourself of the data. Okay, cool. So what we're going to want to pass into the bag of words vectorizer, and or maybe more broadly thinking, we want to take text and be able to predict whether or not it is positive or negative. So our X, the thing that we're passing into our model, is going to be the text, and our Y is the category or the sentiment, so that's positive or negative. So it's probably worthwhile splitting our training data into like training X, or maybe I'll just call this train X, and train Y. So to get just the text for X, we can do a little list comprehension. So we could do x.text for X in training. And for train Y, we can pretty easily do x.sentiment for X in training. So now going back to what we were just doing with the text, if I did train X 0, now I don't have to do .text, and you see that text we already saw is there. Similarly, train Y should tell us that positive sentiment, and as you see, it's positive. So now we've split it up to actually be our X. The X is what we pass in, and then the Y is what we're trying to predict. So for training, we use X and Y together to like know how to build our model, and then when we're testing, we test on just test X, which is going to be x.text for X in test, and test Y would be same thing as train Y, x.sentiment for X in test. So when we're trying to test how our model does, we'd pass in just test X and see if it matches up closely with test Y. But that will be in a sec. Okay, so sorry, I got sidetracked. But bag of words vectorization on this. So once again, this is the common theme. We have this bag of words method that we want to do, but how do we actually do it with sklearn? Well, let's just do another quick Google search. sklearn bag of words is probably a safe bet. What happens? So we get a bunch of these responses, and once again, first two, probably either of these ones are going to be good options. I'm going to just click on working with text data here. Looks like there's a little bit of mumble jumble, but let's look up bag of words in this. Bag of words. Bags of words. Okay, bags of words. Okay, in order to perform machine learning on text documents, we need to first turn text content into numerical feature vectors. So that's what we've been talking about in this tutorial so far. Most intuitive way to do so is bag of words representation. So they have a little description in it here, and then as we see right here, it looks like they're actually doing it with sklearn. So this looks super easy. We can kind of just copy these lines. So I'll copy this line right here, And then CountVec. Okay, cool. And maybe actually what's useful is to actually look up that CountVectorizer, because that's really what we're going to want to do use, because it just showed it in an example. And if we go down here, what often is even most helpful when I'm like trying to get familiar with a certain sklearn library or tool or method is to find the example. They always provide examples in the documentation. And so if I look at this example, it has these 4 documents in its corpus. And as you can see, it extracts out these features here. And if you remember bag of words that we just went over, this is the last feature. So for the first document, the word this appears. So there should be a 1 in the last spot for the first document. It is. Does the word third appear in the first document? No, it does not. So 0. Cool. This is what we want. And the one thing to note that is slightly different is it's not a binary thing with this CountVectorizer by default. Like for the second document, it has 2 occurrences of document, and that's represented with the 2 here. And I think there should be a way to make this binary, so you could just do 1 or 0. I would have to double check that. Yeah, actually binary right here. So non-zero counts would be just set to 1 as opposed to 2. So you can play around and see what works better for your model. But let's go ahead and actually do this now with our thing. So I copy that in. One thing to note is if you want to use that Shift-Tab method to see the docs, you have to run your cell first. It won't know what it's looking for unless you do that. I tripped myself up a little while ago by not doing that. Okay, so what's in that example? Vectorizer equals CountVectorizer. We'll just copy that into our cell as well. Maybe I'll just copy it from here. Okay, character equals CountVectorizer, and then it does fit transform corpus. Okay, and vectorizer.fit transform, and now our corpus, instead of being the little review corpus they showed us here, it's actually just all of our training reviews, so it'd be trainx. And so what do we get when we run that? A really big matrix. So it's a 670, so that's every one of our training values. So all of those have their own row, and each one of those rows has 7,372 columns. So this is a really, really massive matrix. It's a lot bigger than this little example matrix. But then again, if we think about this, it makes sense why it's bigger, because we have now 670 documents that are all longer than these pieces of text. So like our matrix is pretty dang big, but to our computer, it's not that big of a deal. So we're going to be totally fine with this vectorizer. Okay, now that we have this vectorizer, we can go ahead and start getting ready to actually build a model around it. So basically, what this outputted and what we see right here is what we're actually going to want to use as our training input. So like we had before, we had train x, which equal, let's just like print out the first train x. And I'll just ignore this real quick. So that was just like a piece of text. What this now outputs is like train x vectors equals that. And now if we did train x vectors 0, we get a matrix that represented, I'm going to just print both of these things. Basically, so we had this text, and now this train x vectors here is a matrix that represents this text. So it has ones, as you can see here, in all of the positions, or actually it's counting, so 2 for a specific word, all the positions that are non-zero in our matrix. And if you wanted to see that in a more traditional way, I think you could go to array. And this is the entire matrix, but because it was 7,372, we don't get to see the whole thing. But just know that inside of this, there's a 1 wherever this piece of text triggered something in our vectorizer. If that hopefully makes sense. All right. And one thing that also I just find useful to know is that in this step right here, we kind of did two steps at once. We fit a vectorizer to this training data, and then we also transformed our training data to give us these train X vectors. You can do this the same way in two steps. There's basically two separate functions you could use. So you could do first vectorizer.fit train X, and that won't do anything. That will just fit the training data. And then if you did train X vectors equals vectorizer dot transform train X, then you will get the final same result. So what I'm saying is that these two steps, fit and transform, in this function fit transform, they're the exact same thing. They just lumped it in because you so often want to fit a model then transform things. They also have this kind of helpful 2-in-1 function. But doing that in two steps would have been the same thing. Just useful to know because most every like sklearn thing has like a fit transform, fit and transform. And usually you'll want to fit and transform it first. But now actually when we like played around with getting our test X vectors, so numerical representations of our test set text, we could just do vectorizer dot transform because we don't want to like fit a new model, so we just transform it to text X. Okay, so we have with this train X vectors, now our final data basically is train X vectors and train Y. And basically we'll want to fit a model around these. So let's start looking at choosing the right model. Okay, we have our X's and our Y's. Now let's actually do some classification. And sklearn offers a ton of different classifiers. So I'm going to just kind of go through some of the options. And this is a big part of like, there's all these options for classifiers, but unless you kind of study up on these classifiers and get a little bit of like a more theoretical understanding of them, it's hard to sometimes make a decision. So like here's an example, classifier comparison. You can see all of these different types of classifiers that are all built super easily through sklearn. And what I would recommend is if you're trying to like figure out what classifier is right, do some additional Google searching, watch some YouTube videos on these. I know like MIT OpenCourseWare, the actual professor that I had when I was taking an AI class at MIT, who unfortunately passed away, but like if I looked up like linear SVM, MIT, you'd get all of these lectures that are good information. You get a more theoretical understanding. So you can kind of go through and like figure out what, get a feel for these different models and maybe have a feel for which one's going to be better. The other part of that though is, part of it is just testing, just training your model, running it on the test data, seeing what performs better. So we'll take a couple of these, fit a couple of different models and see kind of how they perform. So we're going to take an SVM. We'll probably take both of these with the linear kernel, all that. So that will be one. Probably do some sort of decision tree. I'll throw in some sort of naive Bayes. Maybe we'll also do, I think, logistic regression, which is not here, but okay, so we'll import SVM to start. Okay, so classification. Start with a linear SVM. Okay, and it's very straightforward to use this. We can just do classifier, and I'm just going to say classifier SVM, SVC, support vector classifier, I think it stands for. Oftentimes you also see support vector machine, SVM. Or actually I think more generally you can do from sklearn import SVM, and we can do svm.svc And if I run this and just look up the documentation here, there's a couple things we pass in: the kernel, C value, and yeah, reading the documentation, the penalty parameter C of the error term. If you read up on the theory, you'll have a little bit more idea of these different parameters. It's good to know what you can play around with. So we're going to make this linear to start. So we're going to say kernel equals linear, but we could look at all the different options, like kernel is one option, C is another parameter we can play with, gamma is another parameter, all sorts of stuff. So we have kernel linear, and that would give us a classifier. And all we have to do to fit this classifier to our x's and y's that we defined right here is we can do clf.svm, and this should be a familiar command to you, fit train x vectors and train y. So we pass in an x and y to fit this classifier to our data. There we go. And then what's cool is we could go ahead and predict something. So based on all of the training reviews we had, we could go ahead and do clf svm dot predict, and real quick we need to get something to predict. So maybe we just look up, I'm going to just copy I'm going to print out real quick our test x 0. Let's see. So this is a positive reveal. Looks like we could also get the vector for that. Oh, oops. Test x vectors 0. I think I defined that, maybe not. Train x vectors. So to get test x vectors, we can do, this should have probably been defined up here, test x vectors equals vectorizer, and we don't want to fit again, we just want to transform because this is our test data, test x. Okay, now so we have these text x vectors defined, so we have something to pass in, and now what we can do with this trained SVM classifier, we can go ahead and predict whether the words, this review, every new Pickle better is better than the last, this is no exception. We can predict if that's positive or negative. We can do test x or clf svm dot predict. So pretty much all of these classifiers, I think all of these classifiers have a predict method, and then you would pass in that same type of vector that you used to train it, but we haven't actually seen this test vector, so we don't know what the proper output should be, but I'm saying it should be positive if our classifier was trained properly. And as you see, we get positive. Okay, let's go ahead and create a couple other classifiers. So I mentioned a couple that I'll try. I mean, there's so many options to choose from. So we'll do decision tree. We'll have a naive Bayes option. We'll do a, how about a logistic regression? And we're going to just do these rapid fire. It's pretty cool how easy it is to do this. Okay, so let's do decision tree first. If we go back to that comparison thing, we see decision tree classifier here. I can click on that and get the full documentation for that. Okay, look at the example. So it has a fit, probably has a predict too. Cool. Okay, so from sklearn.tree, import that, and then basically we're copying the same code as before. No, I didn't want to do it there. I wanted to do it here. Insert, so below. Copy. So we're doing decision tree real quick. We're And we're going to want to fit that. So classifier, we'll just call it classifier decision equals decision tree classifier. And then once again, like you could look up the docs of this and see what options you have for things to do, and you kind of play around with that to do whatever's best. We can do clf.decision.fit. We're going to do the train x vectors again, same exact, we're fitting it to the same exact data and the train y. And let's see what happens. So we have another classifier. We've just trained decision tree classifier, and we could do the same type of thing. Let's see if it predicts it properly. So as you see, it's like we just built two different classifiers super quickly. And this said +2. We could go naive Bayes, and I'm going to keep saying this. Like, check out, read into these different classifiers. Like, with me just saying, it's like you're just kind of randomly, there's no like thought process in choosing one over the other. So you kind of get if you have some understanding behind the scenes of how these work, you'll have better ability to do model selection. So naive Bayes, and this time I'll just like look up something else. I'll read from some different classifiers, Scikit Learn. There's all sorts of documentation, all sorts of different types of classifiers here. So I want a naive Bayes. So we'll try just this Gaussian naive Bayes. Okay, now kind of basically just repeat the same thing. Paste in this code. This will be Gaussian naive Bayes. Gaussian naive Bayes. That's like a tongue twister. Gaussian naive Bayes. So what happens here? Same type of deal. Cool. Logistic regression would be the last one. I'm just rapid fire doing these. Logistic regression, Scikit Learn. How do I get you? Okay. Cool. I'll call this clf log equals logistic. And then we'll just copy this. What happened? Okay. So there's some future warnings, but everything's fine. Everything's predicting positive. That all seems good. Okay, now that we have some trained models, let's actually evaluate these a little bit more comprehensively. So let's look at the entire test set and see how accurately we predict every one of those test examples. So like above, we seem to predict positive correctly for every one of these models. So that looks good, at least initially. So how can we do this a little bit more comprehensively? We can go ahead and do, let's just real quick look, just to show you where you would find it. Naive Bayes would work. So what are the functions you can do with that classifier that we train? Or maybe I'll just look up like SVM, Scikit Learn. Because there's a specific function I'm looking for. I just want to show you where you'd find it in the documentation. Okay, score, this is what it is. So we pass in an X and the Y, and it will predict all the X's and see how it compares to Y. So score is what we're looking for. And if I clicked on score, you would see probably how to use it in an example. Maybe not, but you could look up score example, but here's how we use it. Let's take our SVM classifier, pass in the test x vectors, that's what we want to convert, and see how this predictions for this compares to our actual test y. Sorry, svm.score. Now it should work. 82% is not too bad. Let's see how the other ones do. What was the second one I did? I think decision.score, and passing the same exact vectors. So we're just quickly seeing the accuracy. This score function, if we look at it, I could look at it here, or right here, returns the mean accuracy on a given test data and labels. So sounds good. So what would be, we could print all of these. So that's the first one, the SVM, printed out the second one. Let's just copy this 2 lines to get our last 2. Okay, we had the Gaussian naive Bayes, and we had a logistic regression. Okay, let's see how all these do. 82, 78, 78, 84, okay. All very good, which is pretty nice because we didn't do much at all. But is there a catch? And I'm going to tell you right now, there is a catch. So we just looked up the accuracy. The other metric, like accuracy is one thing, like how many labels did you actually predict correctly. The more important metric that we usually care about as a data scientist, I would say, when we're doing classification tasks, is the F1 score. So I'm just going to shorten this line up. So this right here was the mean accuracy on all of our test labels. Let's look up how our F1 scores are for these same exact classifiers. So to use F1 score in sklearn, you can import it like this, and then if I run that, we can do a little look at the signature by doing Shift Tab on your Jupyter Notebook. And so what does it say? Compute the F1 score, also known as the balance F score or F measure, and it gives you a little information if you don't know too much about F score on how it's actually calculated. It's worth just looking into that because it is a good measure. So we need to pass in y true and y predicted, and then optionally we can pass in some labels. So labels might be helpful for us. Okay, so we first need to pass in the y true. So for all of our models, this will be the same. It'll just be test y. And then we need to pass in the predicted y. So predicted y would be clf.svm.predict of all of those things in our test x vectors. So we do it like that. So let's see what our F1 score is for the linear SVM. What happened? Target was multi-class, but average equals binary. Okay, we'll try no averaging. I just want to see each individual class how good its F1 score is. So average equals none. Okay, cool. Okay, so what do these numbers mean? Well, it's a little bit clearer if I pass in labels. So labels are going to be equal to sentiment dot positive, sentiment. And there's 3 labels I noticed, so we actually forgot to filter out our neutral labels. So now we were building a classifier to do positive, neutral, and negative instead of just positive or negative. We might switch that. I think we will probably switch that. So we'll go through how to do that. Neutral and sentiment dot positive or negative. So I might just make things clearer. And one thing to note is if I like switch the order here, we now know which ones associate with what. If I switch the order of these labels, just because it might not be clear otherwise. If I put like positive at the back, you'd see the 90 switch to a different location, as you see. So I'm going to go back though because it was more clear. Okay, so we have F1 score of 90% for positive. So it's very good for positive, but it is trash for this model is pretty trash for the neutral and negative labels. So we want to improve that because yes, we can predict positive, but we want to equally be able to predict negative too. And basically right now what our model is doing is always predicting positive, and oftentimes I guess it's right based on our test data split. Okay, let's just see, does this hold true for the other models too? So like try the decision tree, that, oh wow, oh okay. That did very good on positive again, awful on neutral and negative. So this might be the common trend. Gaussian naive Bayes, that is same thing, good on positive, bad on negative and neutral. And finally, logistic regression. Yeah, it almost like looks like it's good on this, but that's 0.093, not 0.93. Okay, so very good positive. They all are very good positive. So now we've discovered something. How can we make our model better on not just positive examples? So that's what we're going to work on next. Okay, when all of these models perform like equally as bad on neutral and negative, you know, I'm not really thinking that it's a model issue right now. I'm thinking it's more of a data issue. So we're going to do a little bit of investigating into our data and just see if we can find anything. So let's look at our training data. So train X. Train X. So remember what train X was. That was all the labels that we used, and we ended up actually converting them to vectors. The thing I'm more curious about is train Y. So let's just look at the first like 5 elements. Okay, and this already is telling. This is in our training data. We have 5 positive things in a row. We could honestly probably, let's look at the entire list. Okay, 5 right in the first 5. Okay, that's kind of telling. We can do train y.count of sentiment.positive, and let's see how many actual positive labels we have. 552. Okay, so remember we had 670 training labels total, and 552 of them are positive. So right away, our models are going to be like heavily biased towards these positive labels because there's way more of them. So we do the same thing for negative, 47 negative labels. So, and I guess the rest would be neutral. So here's our issue. We need to, let's balance our negative and positive data. So let's do that real quick. Because it wouldn't make sense to balance the 47, like if we balanced it exactly with 47, then we'd have 47 positive. That seems like a little bit too little amount of training data. So what I want you to do real quick is we'll actually download a bigger data set. And if you go to my GitHub, go to data, sentiment, download this 10,000 file. That's actually 10,000 reviews instead of the 1,000 that was originally in this. And if you're curious on how I made this 10,000 file, the way was I used this data process file I wrote and basically looked at all the reviews in this massive file that I downloaded from this, what I brushed on here. So right here, I downloaded that, unzipped it, then ran this file on it, changed this final data to 10,000, took 10,000 samples randomly, and then just basically changed the name here. So it's 10,000 examples, so we should be able to get a little bit more negative examples out of that. So, all right. So you download the data, sentiment, book small, click on it, view raw, and or I guess you could even just click and then you would save as and save it just like you saved the first file. Okay, and now what we need to do is go ahead and instead of loading in up here, book small, you need to load in whatever you named it. I called mine book small JSON or book small 10,000 JSON. So I'm gonna run that. I'm gonna do all the same stuff with this. I'll do the same sort of vectorization. Now it's gonna be a bigger vectorization. And really when we go down here to the count of negatives, we should see a higher number. 436, cool. That's a lot better in my opinion. About 10x for our training data. So we have more negatives, but that also means that we have more positives, 5,611. So what we're going to do is actually create a little container class for our reviews, so we can call it evenly distribute method that will even out our training data and our test data. So we'll do that in the same spot that we created this original data class. So instead of, we have this review class, and now what we're going to do is add one more class, and that's going to be review container. And to initialize that, we will want self as always, and then reviews. And the reviews we already know what are. Self.reviews equals reviews. And we can create a method called, and I'm making this a class just because it makes things neater. We'll create a method called evenly distribute. Takes in self. And what that will do is count the number of, it will count the number of negative sentiment things. And it will, okay, so we'll write this and just bear with me. So we want to get all of our negative examples from the reviews. So what we'll do to do that is we're going to filter our reviews list based on what is equal to negative. So this is a little bit of a, so filter, bear with me, x.sentiment. We want all of our reviews, the sentiment of our reviews, to be equal to sentiment.negative, and that will be done on the entire review. So self.reviews. I think that's good. And I'll just print negative real quick so we can see what this is doing. Basically what it's doing, and I'm not gonna actually print negative, it's looking at all these reviews, mapping every sentiment, and it's basically just filtering based on every sentiment is negative. So whenever the sentiment's negative, we're keeping track of that in the negative list here. And we can do the same thing for positive. Equals filter. I'll just copy this line. And we want this to be positive. I'm going to ignore, at this point, we're going to ignore the neutral examples. You could factor those in if you wanted to. But I'm just going to make sure that my negative values is equal to my positive values. I think this should build our model, make it a little bit better. Okay. So now, if I printed out the length of negative and positive, and I could do that if I rerun this, review container, I could pass in all my reviews somewhere down here. I could pass in like equals review container of training, and we'll just run container.evenly distribute. Okay, so we have positive and negative in here, and what I'm going to just do to just see what's happening is we'll do print negative 0 dot text, print negative, print I guess length of negative, and we'll print the length of positive. Okay, so what happens when we run this down here? Filter is not subscriptable. That is because we now need to convert this to a list. When we filter something, it doesn't automatically convert it back to a list, so you need to surround it with the list blocks. And now what happens here? Cool. So it gives us our text from the negative, shows us that we have 436 pieces of text, and there's 5,611 positive. So what we're going to do is just basically shrink the amount of positive examples to be equal to the length of the negative. So that is equal to positive length negative. And I guess, yeah, okay. So that's equal to the length of negative. And now what we're going to do is our final reviews is going to be equal to negative plus positive shrunk. So now what we're basically doing is shrinking the amount of reviews we're actually storing and just only containing the negative ones and the positive ones that are equal to the amount of the negative. And just for good measure, we're going to also import random. I think this might be overkill. I might be doing this twice, and we're going to shuffle those reviews and just make sure that our data is kind of evenly and random when the negatives and the positives come. Actually, yeah, we do need to do this because otherwise we'd have all the negatives and then all the positives. So we're just going to shuffle up the order so that you don't know if a negative or a positive is coming next. Some of the algorithmic models this will be important for. Okay, cool. So we're going to rerun that. Hopefully everything works. Remember, we imported random here too. Okay, now if we go down to our evenly distribute, and if we run that, actually that's container.reviews, and then we'll just get the length of that. We'll just see if the total number of reviews now that we're looking at are smaller. And then I'll do a couple additional things. Okay, 872. So that sounds like exactly in the middle of, how many negative there were times 2. Okay, so now instead of doing this, we can all kind of bake a lot of this stuff into our container type now. So I'm going to just call this like train container. And we'll make a test container too. And you'll see all of what I'm doing in a sec. And I want to note too, real quick, part of the reason I'm doing this and breaking things out into classes, it's not necessary, but like real world, this is like a real world tutorial, and it's always important to try to like keep your stuff neat. And even though this is easy enough to do, if we have to do this a lot of times, it might get annoying. So we'll bake in some of this breakdown into our review container class. So what we could do is add a couple of new methods. We could do def get text self, and all that would do is return this basically. And not training would be actually in self.reviews. Return, we could get y or get our labels, so get sentiment, I'll say, self. That would be return x.sentiment for x in review self.reviews. And now what I can do is, instead of doing this, train x now just becomes train container dot get text, and train y becomes train container dot get sentiment. Same thing for this. This would be test container dot get text and test container dot get sentiment. Okay. And now what we can do is we could like do something like actually check in our train y the count of self.sentiment, or sorry, train y the count of sentiment dot positive and the count of sentiment dot negative. Review container has no attribute. I don't think I ran this cell again. Run and run and run. 436 is negative. Let's see about positive. 5,611. Okay, it didn't quite do what we wanted it to do, and that's because we also just need to real quick run that function that we wrote called evenly distribute. Now we should be good. Okay, now positive is 436 and negative should be the same. That was a fairly long aside, but yeah, we got to what we were doing. And now, does that help us out? And I don't think it's actually important to evenly distribute test x, but you could if you wanted to. It really depends on what you think your incoming data will be in like practice. All right, so we have this now equal, so we're going to vectorize it the same way using our slimmed down train x and train x vectors. Okay, that's good. Test x vectors. We could also bake this into our review container class if we wanted to, but it's fine like this for now. Okay, now we're fitting to the new data, and we can fit all of these to the new data. And let's see what happens to our scores. Come on, baby. Okay, our scores decreased. Is it a good thing or bad thing? I mean, normally you'd say that's a bad thing, but let's see our F1 scores. How do they look? And our F1 scores, I mean, overall, they seem to get a bit better. I'm not going to look at logistic regression. Let's look at the SVM for now. Okay, I mean, it got definitely better. It's still not great, but it got better. So what can we do next? Let's like keep getting better and better. So the first thing I'm going to say we should do, and you know, as a data scientist, we get to kind of control the data. I'm going to say that I want a model that kind of does a good job predicting when about half and half are positive and negative. So right now in our test set, we have an overwhelming amount of positive. I can show you that. Test-y.count is 2,767 for positive, and now we have 208 for negative. So why this F1 score for negative, and also we dropped neutral out of this completely, so I could actually just kind of delete that from my labels. And also for the time being, let's just focus on this SVM because it's hard to go through every one of these. I would say in general for this model, probably logistic regression or the SVM will be your best performing. Okay, so the reason that this is low is because we trained it equally, but in our test set we only have 208 negatives. So like our model is a little bit more custom to like predict 50-50. And you know, it really depends on what you're looking for, and there's also ways to probably make it a little bit more robust where even though you train with about 50-50, you still could handle that uncertainty. But I'm going to just go ahead and start out by doing the evenly distribute for the test container as well. So now we'll get about 200 for both positive and negative. And everything else should stay the same here. Nothing changed. Nothing changed here. All of this stays the same. Now we can just go back and let's see what happens to our F1 score now that we made it about half and half. So we basically what was happening before is we probably were getting a lot of false positives. If there was something that was actually like a positive comment, we were predicting it negative because we were about equal, like predicting positive and negative based on it. So let's see what happens now that we make this, we evened it out. So I mean, sorry, this is not the model I'm running, but as you can see, 208, 208. Okay, let's see what happens to our F1 score for negative. it shouldn't predict, I mean, it should predict negative at a higher accurate rate because it's tested it even. What happened? I think I didn't like reset things, so I was like doing some weird stuff. Okay, what's gonna happen now? Come on, work. Okay, cool. And look at that. Yeah, it shot way up because it wasn't predicting negative so frequently. Or, I mean, it was predicting negative as equally, but our actual test data was more equally distributed. And I'm saying that we wanted that. All right. So we got like our base model working. And one thing that's probably good to do is let's do a little bit of a qualitative analysis as well. So we could take a test set, such as the one I showed before. We could transform that using our vectorizer. And that's our new, and then we could use the SVM to predict what our labels should be. And as we see, look at that, positive, negative, negative. And we could, it's really kind of fun to play around with this. Great. Positive still. If I said like not great, I'm actually curious what this will say. I think the great will outweigh it because we didn't actually use bigrams, which would count this as one thing. Oh wow, not great. Wow, that's pretty impressive. Very good book. Positive. Very brilliant. All sorts of words. Okay, I guess it didn't know the word brilliant, and that could probably be accounted for with more training data. Very fun. That's good. So, looks pretty good to me, but let's make this even better. Sorry, I'm going insane. Okay, and also just really quick gonna refresh all these scores since we changed up our test data. And as you see, they increase because they're predicting positive and negative both more accurately. Okay, so let's drive up these scores any higher, even higher. And the first way we're going to do that, and this you're going to have a feel for vectorizers, but let's scroll back up to our vectorizer. With the CountVectorizer, let's think of our examples that I showed when I was initially introducing bag words. This book is great was one, and I think the other was this book was so bad. Okay, so with the CountVectorizer, the main issue is that it weights each word equally, even though if certain words don't have nearly as much meaning to a sentence. So like in this case, this and great would be weighted equally as like one count, while the great is the one that defines the sentiment and the this has no meaning really. So instead of using CountVectorizer, we can do something smarter, and that is use a Tfidf Vectorizer. And that stands for term frequency inverse document frequency. So basically, a term is important if it occurs a lot throughout a review. It's like great only appears once, but I guess it's as important as any of these words. And its inverse document frequency means a word is less important if it occurs in a lot of documents. So for example, this, is, was, so. If we had a big corpus of documents, those words would appear a ton. And as a result, their weight would be less than great, who occurs, but occurs less frequently and ultimately plays more of a role into the meaning of the document or the review or whatever you want to call these. So Tfidf allows us to weight this, great and bad, higher than stuff like this and book. And that ultimately will help our performance. So all we have to do to make this change is change this to Tfidf Vectorizer. And we should be able to run this. We should be able to rebuild our models. And oh no, I updated it really quickly. But If I'm not mistaken, by doing that, if we're focusing just on SVM, that went up by about a percentage point, it looked like. So it did some damage, and you probably could tweak around with that, make it even better. I think logistic regression actually went down. But so, I mean, this is, machine learning in general. Like, you do something, maybe it increases it, maybe it doesn't. Try to be smart about how you do things, and you always kind of just have to play around and try things. But our SVM went up. Okay, that's cool. So that's one thing we can do to increase our performance. Let's see what happens to our F1 scores for SVM. Yeah, they seem to both go up for both sentiment, positive and negative. That's cool. And I'm guessing these will stay the same, hopefully. Yeah. All right, so we're going to try to increase our accuracy even further. And we'll be doing that through a method called GridSearch. And to access GridSearch, we can do from sklearn.model selection import GridSearchCv. And if I was like uncertain what this was called, I would probably be Googling like parameter tuning sklearn, and you'd probably find this by doing that. Okay, so GridSearch CV, and what does that do? Well, let's go back to our SVM, that SVC model that we used, and I'm going to real quick look up the docs for this. So as you see, there's a bunch of different things that we can pass into our SVC. There's this C parameter, there's this kernel, degree, gamma, all of this stuff. And to be honest, like, especially for like stuff like the C value, maybe kernel, you have a better feel. I don't know what values that are going to be best for my data. So is there a way I can programmatically test a lot of different options and like choose the best one for me? And that's exactly where this GridSearchCv comes in. So we'll do something called like tuned SVM equals. And how do we use grid search? Well, and I'll actually get back to that in a sec. I'll comment this out real quick. Well, what are the parameters we were looking at? Well, C, kernel, gamma. Well, let's just focus on the C value and kernel value right now. And remember, for kernel, we were using a linear, but you can also use one of these. So we're going to pass in some parameters. So what are our parameters going to be? They're going to be, first off, we'll have kernel. And for now, I'm just going to list in 2 kernel options. So kernel, and I'm going to pass in, this is a dictionary mapping kernel to our options that we want to look at. Linear, so that's what we're currently using. And there's this other one that's the default, that's radial based, I believe. Kernel. So that'll be one of our parameters. We can also pass in a C value. Right now, the default is, I think, 1, as you see here. But maybe 1 isn't the best value. So we can pass in a bunch of different values. We could pass in 1, 4, 8, 16, 32, etc. And basically what's going to happen is when we use this grid search, so I'll say SVC equals svm.svc, classifier equals GridSearchCv of the classifier that we want to pass in. So that's this right here. And then we're going to pass in the parameters. And then we can optionally pass in the CV value, which is basically how many times it wants us to split the data up to like cross-validate and make sure that things are working well with the specific parameter on our training set. So now we have our classifier defined, and we can do classifier.fit train x, train y. So we're fitting it just like we fit all of these other models up here, or up here. Train x vectors, I guess I have to pass in. Train x vectors, train y. Okay, and so now what's going to happen is it will check linear kernel, it will look at, for this linear kernel, it will check all of these C values, figure out what's the best option, and then it will also check this RBF kernel and check all of these C values. And then it will choose a kernel and a C value that it predicts will do the best on unseen data. So let's fit that. This sometimes will take a little while depending on how many parameters you pass in. I don't actually know how long this will take. We'll see. Oh, it worked. Okay, cool. So it found, after doing this, that it's found that it was a good value that we put in. One was fine, but it actually changed our kernel value. It recommended the radial-based kernel. So now we have a new classifier. And if we went ahead and did the same scoring method that we've done on the other values, and I'll do this in the next cell so we don't have to rerun this. Okay, so remember our SVM before was 80.7% accurate, and now let's see what happens after we did a little bit of fine tuning. Oh, it's about the same. I guess that RBF kernel didn't do much. Kind of coming down to the end of this first model. I mean, there's room for improvement here. A couple things you could do if you wanted to improve any of these models further. Specifically, I'm just focused on this SVM that we just fit. I guess this is really pretty general for all of them. Think about how what our text looked like. Like, one thing you could potentially do is just strip out any of like the frequent words. Maybe that would help a bit. One thing I noticed that might be a problem is, let me just insert a cell, is that words like good and good, they probably would treat this, I think by default, you're not stripping out punctuation. So like good explanation and good would be treated as different words. So like one thing you could do to make your model better is strip out all of the punctuation marks. What else could you do? You could look at exploring more complex things than just doing bag of words and Tfidf Vectorization. There's a lot of cool state-of-the-art language models that are out there. There's OpenAI's GPT that maybe you could do something cool with. There's Google's BERT, that's also good. Those are both topics for maybe future videos. But this also isn't a natural language processing video, so I'm not going to cover the future areas. So let's talk about saving the model. Okay, so we have this classifier right here that we want to save so that we don't have to retrain it the next time we want to use it. Well, we can do that very easily with this library called Pickle. So if you should, I think, have Pickle maybe by default, but if you don't, you can do a pip install of Pickle and get it. And basically what we can do with this Pickle library is I can do with open, I've created some directory, let me see where I am, one sec. And you can actually, so in my sklearn directory, I have this models, and I'm going to save a model here. So models / sentiment classifier .pickle. That's what we're going to save our classifier as. So with open sentiment classifier pickle, and we need to write there, so we're going to open it as writing buffer as f. We can do pickle.dump clf to f. So this is taking our classifier that we were using up here, basically the SVM, but with some tune parameters that ended up being basically the same parameters, giving us the same result. We have this, and we're dumping it into all of the parameters in here into this file. So I can run that. Now what's cool is that I can go ahead and, even if this CLF wasn't defined, or if I wanted to define it as something else, I can just simply load in the model. So I could go ahead and do something like, so I could do, I need to open that file. So I can just copy this, open, and now this time I'm reading it, so I should read buffer as F. We want to do classifier, so I'm just going to call loaded clf. And just so you're clear, if I was trying to do loaded clf dot predict now, like, this would not be defined, so it wouldn't work. Loaded clf equals pickle dot load, and I just need to load that file. Do that. Now I can do loaded clf dot predict test x vectors. Let's just test the first one. What is the first one? Test x 0. As you see, it did output something. So like, we have a review that looks like this, and without doing anything before, we didn't have to retrain a model. We were able to just load this pickled file and use it just as we were using the classifier before, after the training. So that's pretty cool. It's very, very useful, because if you're training these models, you want to be able to save, you want to be able to use them in production, and using this pickle by dumping your trained models and then reloading them, that's how you're going to do this. Because this tutorial is getting pretty long now that we're done through everything, I'm going to kind of skip over the category classifier, or I'll go through it really quickly. It is on my GitHub, so if you want to see this exact details, check there. So if you go to sklearn, Galli/sklearn, and you go into the category classifier, you could download this too. You'll see that it's basically the same thing overall as what we did before. A couple differences, like I added an enum class for categories. Basically, then we go through and load in data from all these different files, and all that data can easily be found through data/category. You download all of these files, and then so it goes through each one of these files, loads in all the data associated with that file, and then based on which file I loaded from, it sets a specific category, and that can be seen here. To that, it adds the reviews the same way, preps the data pretty similarly. One thing you'll notice is that evenly distribute is crossed out, because for this one, because we're looking at just which category, so electronics or clothing or grocery that a review comes from, we don't care whether the positive and negative stuff is evenly distributed. At least I don't think it would be that important to. We use the Tfidf Vectorizer just like before. Here's some classification stuff. Pretty similar. F1 score does actually very well, as you can see with here. All of these are like hitting pretty accurately across the board, so that's pretty impressive to see. Do the grid search again, and that honestly just gets you back to, even though you had all these options to choose from, it gets you back to C equals 1 and kernel equals RBF, but it did check all of these. Finally, like, saved the pickle file. And also saved the vectorizer in this case, because it's nice. Basically, when you want to do tests like this, like quick kind of qualitative tests, you want to use the vectorizer as well. So figured I would save the vectorizer as well. Those pickle files you can download from my GitHub as well. They're in the models directory. Then the last thing I did here, which was kind of cool just because it fit well, was I did a little bit of a confusion matrix. So you can look at this code. Basically, as you see, the stuff across this diagonal is, so on the upper axis is, I'd have to double check this actually, but one of these is the Y predictions, and one of these is the Y actuals. So as you see, it's very, Y prediction and Y actual are very close, but maybe sometimes, you mistake clothing for electronics. You mistake books for grocery. Like, there are mistakes, and that's what the confusion matrix shows. But you could use this code if you want to replicate some confusion matrix type stuff. All right, that's all we're going to do in this video. Thank you guys for watching. If you enjoyed this video, make sure to throw it a big thumbs up. Also, it would mean a lot to me if you don't mind subscribing. Really, just seeing more subscribers motivates me to make more videos. Also, check out my socials, my Instagram, Twitter. And then final thing I wanted to say is if you like this dope shirt that I'm wearing, you should definitely check out my buddy Sebastian. His Instagram page where he makes all this cool content is right here, and I'll also link it in the description. Thanks again, guys. Peace out.